Okay, this is Unit 2 Atomic Theory, Lesson 6. We've only got about one more lesson left in this unit, and that will be it for atomic structure. So today we're going to talk about electron shell diagrams and Lewis dot diagrams. Before we get started, I want to do a little bit of a review of electron configurations. It's been a while since our last lesson. So let's just review. If we're looking at chlorine, underneath the element chlorine it says 287. This is the electron configuration. First of all, the 7, remember the last digit is the valence electrons. So I'm just going to put valence E. And the first two combined make up what's called the kernel. So everything but the valence. So this has 7 valence electrons and 10 kernel electrons. The other thing that's important about the electron configuration, again, I'm going to rewrite it down here, 287. It tells us exactly how many are in each principal energy level. So in the first principal energy level, I've got 2 valence electrons. I'll just put PEL for principal energy level. In the second principal energy level, I've got 8 electrons. And in the third principal energy level, I've got 7 electrons. So basically what we are going to be doing is we are going to be drawing some board diagrams that shows exactly the layout of the subatomic particles. So let's just use chlorine as an example here so you can see what we're going to be doing. Chlorine's atomic number 17, so it's got 17 protons. So I'll just put this up here, 17, and it has a mass number of 35.4, so that's about 35. So 17 subtracted from 35 gives us our neutrons, which is 18. So that's found in the nucleus. And then in our first principal energy level, we've got 2 electrons. In our second, we've got 8. And then in our third, rough diagram here, we've got 7. So that's normally how we would draw a whole board diagram, but that's very time consuming. Another way of cheating to do it, and is how I'm going to do it in our packet to save time, 17 protons, 18 neutrons in my nucleus. I've got 3 shells, 1, 2, 3. I've got 2 in this one, 8 in this one, and 7 in this one. And you just have to realize that if we were to draw the whole thing out, you'd be drawing your circles and putting all your little dots. So let's get started. Let's start with carbon. Carbon has an electron configuration of 2-4. It has an atomic number of 6, so it's got 6 protons, and you can look on your reference table, you can follow along where I'm getting these numbers. It's got an atomic mass of 12, so carbon 12, that's the mass. 12 minus 6 is going to give us 6 neutrons, so there's our nucleus. And in our first shell, we've got 2 electrons, in our second, we've got 4. And normally, like I said, I would draw the circles and put 2 dots on the first circle and 4 on the second, but that's going to be very time consuming to do 8. Fluorine has an electron configuration of 2-7. It has a mass number of 19, and it is atomic number 9. So it's got 9 protons. 19 minus 9 is 10 neutrons. There's my nucleus. In the first shell, it's got 2. In the second shell, it's got 7. Beryllium is atomic number 4. It has an electron configuration of 2-2, and its mass is 9. So if it's got 4 protons, 9 minus 4 is going to give us 5 neutrons. It's got 2 in the first and 2 in the second. One thing I want to point out, remember that your protons equal your electrons in a neutral atom. So here's 4 protons, 2 and 2 is 4 electrons, 9 protons, 2 and 7, 9 electrons. So your protons equal your electrons in a neutral atom. Aluminum, electron configuration 283. It has an atomic mass of 27, and it has an atomic number of 13. So 13 protons, 27 minus 13 is 14 neutrons. It's got 3 shells, 2, 8, 3. Lithium. Lithium has an electron configuration of 2-1. It has an atomic number of 3 and a mass number of 7. So 3 protons, 7 minus 3 is 4 neutrons. 2 electrons in the first shell, 1 in the second. Iodine. Iodine has an electron configuration of 2, 8, 18, 18, 7. It's a big one. And it has 127 as a mass number. So it's got 53 protons, and it's going to have 74 neutrons. And I'm not going to be able to draw all these shells. So we've got 5 shells. 1, 2, 3, 4, 5. Yeah, I definitely was going to draw those dots. 2, 8, 18, 18, 7. Okay, now we talk about ions. Things are a little different. Before you draw the diagram, you want to figure out how many electrons you have. So if we look at sodium, a regular sodium atom has an electron configuration of 281. The +1 means that it lost one. So it lost that one. So sodium, or Na+, is going to be 2, 8. The mass number hasn't changed because mass number is made up of neutrons and protons, not electrons. So our mass number is still 23. And our atomic number hasn't changed. So it's got 11 protons. 23 minus 11 is 12 neutrons. And now it's only got 2 principal energy levels. 2 here, 8 here. Okay, the last one, sulfur. Regular sulfur is normally 286. But this is telling us that it gained 2. So it gained 2 here. So this is going to give us a total of 8 in our last shell. So this is 288. Sulfur has a mass number of 32, and it has 16 protons. 32 minus 16 is 16, so it's got 16 neutrons. And this would be 2, 8, 8. So that's just a little bit about how you can draw them. Like I said, I didn't draw the full circles. It was way too time consuming. All right, let's move on. We're going to talk about Lewis electron dot diagrams. This is actually a shorter way of expressing electron location. It's an easier method because it only illustrates valence electron. Configuration. So you're only showing what's in the outermost shell. So it's really easy. The first thing you do is write the element symbol. Then you retrieve the electron configuration from the periodic table, and the last number in the configuration is the valence electrons. which you already know. You're going to arrange the dots around the symbol using the following rules. Only 2 electrons max per side. Therefore, if you have 4 sides, you can't have more than 8. 8 is great. 8 means that they're happy, stable, content. And we always pair the first 2. If you have more than 2, you'll deal with them one at a time on the other 3 sides till you run out. This is not correct here. So I want you to put an X through that. And this is where you put your valence electrons. You do the first one, 1, 2, 3, 4, 5, 6, 7, 8. I guess it was partially right. It was missing some of the numbers. It was missing the side numbers. So let me show you how we do this. In an example, let's look at, let's take selenium, Se. Selenium. And selenium, if you look at the electron configuration, says 2, 8, 18, 6. So its configuration is 2, 8, 18, 6. All we're interested in is this. And we're going to put dots. 1 for each electron, valence electron. So we're going to go 1, 2, because you always do 2 together first. Then 3, clockwise. 4, 5, that one's filled. 6, 7, 8. Very easy. Oh, one last rule. If you are working with an ion, you must adjust the valence electrons. Add or subtract the electrons in the configuration before constructing your dot diagram. Be sure to draw your final diagram with the initial charge on the ion. And you need to use brackets. So, for example, if I have carbon minus 4. If I look at carbon's electron configuration, it says 2, 4. But the minus 4 means that I've added 4. So that means that my new configuration is really 2, 8. So I'm going to draw carbon. 1, 2, 3, 4, 5, 6, 7, 8. This is an ion, so we need to put brackets around it because it's an ion, square brackets, and we need to include the charge. So we need to have the initial charge on the ion and brackets. So let's do some practice ones. So argon is located in group 18. It has an electron configuration of 288. Remember, I'm only interested in the last number. So argon, 1, 2, 3, 4, 5, 6, 7, 8. Done. Phosphorus. Phosphorus has an electron configuration of 2, 8, 5. Only interested in the 5. Phosphorus is P. 1, 2, 3, 4, 5. Carbon has an electron configuration of 2, 4. 1, 2, 3, 4. Beryllium has an electron configuration of 2, 2. Only interested in the 2. 1, 2. Oxygen has an electron configuration of 2, 6. 1, 2, 3, 4, 5, 6. Whoops. Aluminum has an electron configuration of 283. So I'm interested in the 3. 1, 2, 3. Sodium has an electron configuration of 281. Na, 1. Bromine has an electron configuration of 2,8,18,7. Only interested in the 7. 1, 2, 3, 4, 5, 6, 7. Now, Na is 281, but this is Na plus 1, so it lost this 1. When it loses this 1, it means that this shell is empty. So we don't put any dots. This shell is now empty, and we put this in brackets, and we put a charge, because this is really now 0. It lost 1. Oxygen is 2, 6 normally. However, the -2 means it gained 2. So now it is 2, 8. So I draw my O. 1, 2, 3, 4, 5, 6, 7, 8. It's an ion. It must have brackets and charge, -2. So ions must have brackets and charge. Okay, and that's it for tonight's lesson. Don't forget to do your quiz on Castle Learning. And if you want the practice test early and you don't want to wait till Monday to get it, please stop by my room tomorrow and I will have the practice test, because we really only have one more lesson in this unit. And we will have a quiz on Tuesday of next week. Okay.